Hey, hello guys. Welcome back with me, Farhan Setiawan from class of Numeric Method 3, and my NPM is 220682410. And as you guys know, now I'm gonna explain to you about my quiz compilation from my perspective and based on my answer before yesterday in my quiz in Numeric Method by Padai. And yeah, before we take some explanation, and I hopefully that explanation can help to you to enhance your personality or self-development. We're gonna take some pray because we must let the God in. Okay, the pray begin. Okay, let's go to the video. The first thing first, we're gonna do based on the first question. The quiz Numeric method is elaborate understanding consistent thinking using the DAI5 concept. The conscious thinking is involve a complex interplay of a cognitive process, including the intention, initial thinking, idealization, and instruction. Here we will explore this component and their roles in shaping our understanding of conscious thinking. Okay, first I'm gonna explain to you about my intention. What is intention actually means? Okay, intentions are a fundamental aspect of conscious will and responsibility. They are the mental states that guide our action and decision, and they play a crucial role of shaping our sense of responsibility for those actions. In this context of conscious will and responsibility, intentions are closely tied to the concept of free will, which is the ability to make choices there that are not determined by external factors, but rather by own desire and goals. Okay. Secondly, we describe about initial thinking. That initial thinking refers to designing invitation involved that the first mental impression and ideas that come to mind when considering the design. This stage is characterized by a rapid and automatic processing of information. Often without conscious awareness, the initial thoughts can be influenced by various factors as a heuristic, bias, and emotion. Okay, third, we're gonna explain to you about idealization. Idealization is upquotes in science that being a feature of both the formulation of laws and the theories of their application to the world. It involves the processing, creating idealized or perfect representation of ourselves, others, and situation, which can be both is positive and negative. Realization can motivate us to strive for excellence and improve ourselves, but it can also lead to unrealistic expectation and disappointment when these expectations are not met. Okay. Lastly is instruction. Instruction is play crucial roles too in shaping our consistent thinking by providing the guidance, structure, and feedback. This guidance can came from the private source, including teachers or the mentor who offer expert guidance and feedback on specific tasks or skills, self-instruction, or where we internalize and regulate our own actions, and social norms that influence our behavior through the cultural and social expectation. Instruction can be explicit, where guidance is directly communicated through verbal or written means, or implicit, where our guidance is conveyed indirectly through the nonverbal cues such as body language, facial expression, environment, signs, and symbols. Okay, there's some conclusion that I got from perplexity about the elaborate of the conscious thinking, that the conscious thinking involves a deliberate and systematic process of understanding and analyzing informations. It involves setting clear goals and objectives, gathering and analyzing information, and envisioning a desired outcome, and providing guidance and direction. Let's move to the next problem that in this case, I'm gonna solve problem using numerical method. As you guys know, numerical methods are techniques used to solve mathematics problems in engineering analysis that cannot be solved analytically. These methods provide approximate but credible solutions to problems that involve nonlinear equation, integration, and differential equation. The accuracy of numerical method solutions depends on the size of the increments of the variable selected for the solutions. Okay, next. I'm gonna explain that I'm on my consciousness to do tasks about engineering problem and solve with a numerical method that and conscious while doing this task, and I'm completely myself right now, especially include in this video, and I'm on my consciousness too that I recognize that many engineering problems are too complex to be solved analytically and require the use of numerical methods to obtain accurate and reliable solution. Okay, next, I'm gonna do my initial thinking. My initial thinkings about numerical method used in engineering problem is based on perspective and my assumption about my what is numerical in general is it that a numerical method is a technique used to resolve mathematical problems that cannot be solved analytically or exactly. These methods involve approximating the solution to a problem using the numerical techniques such as interpolation, extrapolation, and approximation that I acknowledge that numerical method involve approximation and understand the importance of selecting appropriate methods and parameters to ensure that accuracy of the result. Okay. Next, after we do the initial thinking, what is numerical method that we use on do some case or do some solve in engineering problem causes that next we're gonna through the idealization. To solve the complex numerical methods, we know that to utilize some equation and maximize some important parameters. The Ruxkuta in these examples, the Ruxkuta method is a family of iterative methods that use to solve ODE. It is particularly useful for solving problems that involve complex systems such as structural dynamics, heat transfers, and fluid flow within porous media. The method involves approximating the solution at each step by evaluating the function at specific points within the interval of integration. Okay. In this illustration too, I'm gonna explain about my knowledge and what is a Runge-Kutta methods. That Runge-Kutta methods is basically the methods of iterative, implicit, and explicit methods, including the well-known as Euler routine used in temporal discretion for solving ordinary in differential equation. Uh, Simply, in this Runge-Kutta methods is pengembangan from the, as you know, Euler methods, Euler Cauchy, or as you guys um, studied on the before uh, test with Pankos. The Shruta methods is an alternative to Taylor series methods that do not require the derivative calculation. These methods aim to achieve higher accuracy and avoid the need higher order derivative by evaluate the function f xy and select the points within its steps. The Runge-Kutta methods is the most popular PDB or PDB method its due to its widespread use in practice. There's some example about the formula from the Runge-Kutta first order, Rojkuta second order, and Rojkuta third order. Uh, when the as you for your information that Rojkuta order third order is the uh, crucial that used in many application about during iterations and on solve some engineering problem. Okay, by this formula, we can know the K1 equals to HF equal XR and ER for the first order. Y R plus 1 is equal to YR plus A1 K1. For the second order, we got K1 equals to HF XR ER. For the K2 equal to HF X1 plus P1 rho 1 HYR plus Q level Q1 K1. Uh, we obtain the function is YR plus 1 equals to YR plus A1 determined by K1 plus A2 K2. And the third order is optimization from the second order, as you guys know from that. Okay, let's go to the instructions. Okay, instructions in um, numerical methods essential tools for engineering to solve complex problems that cannot be solved analytically. That these methods provide approximate but credible solution and are widely used in various fields engineering, including civil engineering and mechanical and aerospace engineering. Okay, simply is instruction as the step function about the idealization and initial thinking before about how to read the process to solve some engineering problem. The step by step that we are gonna do about to solve a good problem from that. Then we are gonna do some check for the optimization too. Let's go. I'm gonna give you some example about instruction. Okay. In these instructions, I'm gonna take some time about optimize aerodynamics car. That the first thing to do in this uh, instruction is to design the airfoil using an elevator, then simulate in CFD soft NG to obtain lift and drag force at various speeds and angles of attack. After obtain the lift and drag force, create the graph, then obtain the equation from the graph. The obtained equation will simulate Python, resulting in the optimized airfoil design. Uh, After we design, we do some safety. We're gonna we can use numerical methods from optimize what the actually the left that maximum left of the or the maximum drag or the angle of attack can actually can discuss product in dynamics. Okay, this is a footage of design using some tools, utilize some tools. As you guys know, it is Inventor to design the airfoil that we want. Okay, me and I thank you to Fanya Melinda Salsabila that they can be the reference for this instruction of design some airfoil based on the website that Pada use on class of 2018 that we then I gonna take as my reference to my instructions. Okay. Next, I'm gonna do my simulation of CFD soft. That the CFD analysis of airfoils involves solving the Navier stocks or the fluid mechanics equations, which is describe the motion of the fluids and gas. These equations are described using numerical methods such as finite volume method and solved using algorithms like the simple or semi implicit method for pressure equation solver that can be reached at the simulation have the applications. In this case, we're gonna use Safety software. Okay, in these photos that I take from website by Finding Medias Alpha Village. Thank you for it, and I appreciate it. Okay, uh, let's do some para view for the view. Okay, sorry, get the calculator. Okay, para view, as you guys know, in SFD soft can be linearly connect is where this view is an open source application for visualization to and three-dimensional data sets. It is widely used in various files, including CFD, to analyze and visualize complex data sets. And this in context, we are using ParaView, Focus, and arc-oil analysis. That is ParaView, we can get the parameters that we can get if we identify and symbolize in the real life, because which can be see, right? Okay, let's go to the results of this ParaView. Let me reach some left force and drag force by angle of attack. And then we got some equations when the y is minus 0.0000 uh, 27x3 x or x cubic plus uh, 0.2733 x quadrant plus 2.51 0.1534 x min 421817. Okay. Lastly, we're gonna take some numerical method in there by we're gonna do some iterations. That the iteration is a process to involve repeating on the CFD simulation several times and until the desired level that accuracy is achieved. It is done by adjusting the mesh and boundary conditions based on the results of the previous simulation. Okay, results. This is a result for the iteration that this is the application of numerical method that prove as a programming on Python to calculate the total force of drag and total force of left and then optimal to the car. Uh, then the first step is we import the NumPy and import the minimize from Skippy optimize. Then there's some calculation drag as x1 equal x0 drag as you guys know from the equation before. And this for the left force left. Okay. Uh, the objective in this code is to define some uh, angle that if we have some objective and return by calculation of the left x. They have to constrain x for the angle variables to minimize some equations drag, and we have constraints to x for the angle variables to minimize some equations left. We can Defined by calculate of the direct optimal and left optimal by using some Skippy optimize. Yeah, from there. So equals to minimize objective x0 methods equals to SLS QP constraints equals cons and options equals this true x optimals equals to solution x for optimals equals to mean solution function. Okay, after we calculate with this uh, library of Skippy optimize, we can get the solution optimal, the total force optimal, drag force optimal, then lift force optimal by this parameter. Sorry, uh, we can I can't go to make the photos bigger. Sorry. Okay. After we do some knowledge about what is the five concepts, then elaborate the concept thinking to the five. We define some case engineering within the numerical method solutions. After that, we're gonna take some explanations about what is a value added by you uh, studied about day five and what's the value added when you use the value added on day five in real life. Okay, this is to, as you guys know, value added in day five is involve focusing on involve your learning process. That there's five value added that you can get if you studies and you apply in real life to the day five. The first thing is improve the problem solving. Consistent thinking, intention, initial thinking, realization, and instructions can all help uh, engineers that I mentioned because we are engineers to approach problems in the more systematic and structured way, which is can lead to more effective problem solving and decision making. Secondly, enhance the collaborations. Instructions can help engineers to communicate their ideas and intentions more effectively, which can enhance collaboration and teamwork. Increase the motivation, having a clear intention and a clear map of picture or desired outcome can help engineers to stay motivated and focus. And better decision making, consistent thinking and intentions can help engineers to make more informed decisions by recognize and manage their emotion and bias. And also increased creativity that initial thinking and ideation can help engineers to generate new idea, to think outside the box, which can lift more innovation solution on the future. Okay, and don't forget to stay by your values. Don't you take the other or people parameters as your standards, but stay by your values. Okay, plus I'm gonna explain about my self-evaluation on studies day 5 lately and Miss Sampadai, and we talk about many things in this class. Then I got a celebration when using the concept thinking, intention, initial thinking, initiation, and instruction. Self-evaluation plays a crucial role in ensuring that the process is effective and efficient. Consistent thinking involves being aware of one's own thoughts and mental process, including bias, assumption, and emotions. The self-reflection helps to prevent influencing outcome. Intentions are clear, aligned desired outcome through self-relation, preventing misunderstanding and ensuring focus for the further. And initial thinking is evaluate to ensure relevance and alignment with problem, preventing unnecessary detours. Realization is equivalent to ensure realism and achievability, preventing unrealistic expectation. Instruction is clear and effective through self-evaluation, preventing misunderstanding and assuring the correct execution. Self-evaluation involves evaluating one or more main soul process, intentions, and actions, including bias, assumption, and emotion to ensure the problem-solving process is effective everyone at achieving the desire of the outcome. Okay, I think that is from some of my videos about a quiz compilation. Explain it uh, for the tugas besar, and I hope really helpful for you guys. And I hope can do maximize on the other tasks and for the next was. Okay, that is from me. I have it so. Wassalamualaikum warahmatullahi wabarakatuh.